Hello students, in this lecture we will discuss function y is equal to sine inverse of sin x. We will see the domain, range and principal values of this function. Also we will draw the graph of this function and we'll see what are the applications of this graph in problem solving. So we have a function y is equal to fx is equal to sine inverse of sin x. The first thing is, what is the domain of this function? कैसे निकालेंगे इस फंक्शन का डोमेन? हमारी आर्ग्यूमेंट्स क्या होंगी डोमेन निकालने के लिए? ओके, व्हाट इज द डोमेन ऑफ sin inverse x function? The domain of this function is -1 to 1. That means for sin inverse of sin x function, the values of sin x must lie between -1 to 1. sin inverse फंक्शन के अंदर कोई भी फंक्शन आ जाए, उसका एक ही कंडीशन है कि वो फंक्शन के वैल्यूज -1 एंड 1 के बीच में होने चाहिए. So we have sin x between -1 to 1. Now tell me, for which values of x this values of sin x are possible? sin x फंक्शन का रेंज तो ऑलरेडी -1 to 1 होता है, तो यहां पे हम x की कौन सी वैल्यूज ले सकते हैं? We can take any real values of x. So here domain of the function is R. For any real value of x, the values of sin x are -1 to 1, and for this values of sin x, sin inverse of sin x is well defined. What is the range of this function? It's simple. Since sin x lies between -1 to 1, sin inverse of sin x will lie between -π/2 to π/2. So the range of this function is -π/2 to π/2. Now consider this mapping of the function f. We have a function f from set A to B. Set A has two elements a and b, and set B has two elements p and q. We are connecting A to P and B to Q. Now this function is 1 1 and onto function. We can define function from B to A, which is f inverse function. Okay. Now what is f of A? F of A is P, and f inverse P is equal to A. If I put the value of P, I get f inverse of f of A is equal to A. Similarly, we have f of B is equal to Q, and f inverse of Q is equal to B. So we have f inverse of f of B is equal to B. You can see that in the function f inverse of fx, if I put x is equal to A, I get A, and if I put B, I get B. That means here f inverse of fx is equal to x. क्या साइन इनवर्स ऑफ साइन एक्स का वैल्यू हमेशा x होगा? यहां पे डाउट इसलिए है क्योंकि साइन इनवर्स ऑफ साइन एक्स का डोमेन है ऑल रियल नंबर्स, एंड द रेंज ऑफ साइन इनवर्स फंक्शन इज -π/2 to π/2. To understand this, I have one very interesting mechanism. I am putting this 3 scales. The first scale is for values of x, the second scale is for values of sin x, and the third one for sin inverse of sin x. हम देखते हैं कि इस मेथड से हमें ये कितना अच्छे से समझ में आता है. Now let's find the value sin inverse of sin π/6. So we have a point π/6 on the scale of x. For this value of x, sin π/6 is half. So we have a point 1/2 on the scale of sin x, and sin inverse half is π/6. So on the scale of sin inverse of sin x, we have value π/6. So I started with the value π/6 and I am getting the value π/6. Now consider one more value, sin inverse of sin -π/4. For that I put point pi by 4 here. For this value of x, sin x is minus 1 upon root 2. So I have sin inverse minus 1 upon root 2, and the value of this is minus pi by 4. So on the scale of sin inverse of sin x, I put minus pi by 4. So again here I started with minus pi by 4 and I am getting the value minus pi by 4. Try some more values. This time sin inverse of sin 5 pi by 6. So we have a 0.5 pi by 6 here. For this value of x, sin x is half, because 5 pi by 6 is the angle of second quadrant for which sin x is half, and again sin inverse half is pi by 6. This time I am not getting 5 pi by 6, I am getting pi by 6. You can try one more value, say minus 4 pi by 3. That means I am getting the value sin inverse sin minus 4 pi by 3. Sin minus 4 pi by 3. This angle lies in, we have this fourth, third and second quadrant, for which we have value root 3 upon 2. And sin inverse root 3 upon 2 is pi by 3. So again here this is not equal to minus 4 pi by 3. Okay, what we understand from this few such values. If we take any value of x between minus pi by 2 to pi by 2, for which the values of sin x are minus 1 to 1, and for this values of sin x, I get the values of sin inverse of sin x between minus pi by 2 to pi by 2. अगर आप x का वैल्यू माइनस पाई बाय 2 एंड पाई बाय 2 के बीच में लेंगे तो साइन इनवर्स ऑफ साइन x का वैल्यू भी माइनस पाई बाय 2 से पाई बाय 2 के बीच में आएगा एंड सेम वैल्यू आएगा. जैसे पाई बाय 6 के लिए हमें वैल्यू मिला पाई बाय 6, माइनस पाई बाय 4 के लिए वैल्यू मिला हमें माइनस पाई बाय 4. सो वी कैन से हियर साइन इनवर्स ऑफ साइन x इज इक्वल टू x व्हेन x बिलोंग्स टू माइनस पाई बाय 2 टू पाई बाय 2. If I take values of x less than minus pi by 2 or more than pi by 2, in that case sin inverse of sin x is not equal to x. आप x का वैल्यू कोई भी ले लो, less than minus pi by 2 या फिर more than pi by 2 के रीजन में आपका जो sin inverse of sin x का वैल्यू है वो minus pi by 2 and pi by 2 के बीच में आएगा, because the range of this function is माइनस पाई बाय 2 टू पाई बाय 2. किसी भी फंक्शन को अगर हमें प्रिसाइसली समझना हो तो हमें उस फंक्शन का ग्राफ ड्रॉ कर लेना चाहिए. सो लेट्स ड्रॉ द ग्राफ ऑफ फंक्शन y इज इक्वल टू साइन इनवर्स ऑफ साइन x. दिस ग्राफ विल हेल्प अस टू अंडरस्टैंड दिस फंक्शन क्लियरली एंड प्रिसाइसली. व्हाट वी नो अबाउट दिस फंक्शन? The domain of this function is R and the range is minus pi by 2 to pi by 2. जब भी आपको किसी फंक्शन का ग्राफ ड्रॉ करना है तो सबसे पहले उसके जो कंस्ट्रेंट्स हैं, पैरामीटर्स हैं, वो आप समझ लें. जैसे कि यहाँ पे हमने देखा डोमेन एंड रेंज. डोमेन इज R, that means graph will spread over entire x axis. Range is minus pi by 2 to pi by 2. That means the graph will lie between two vertical limits minus pi by 2 and pi by 2. हमें थोड़ा बहुत आइडिया आ जाएगा कि ग्राफ का लोकेशन क्या है, कहां पे होगा ग्राफ. ओके, अब एक स्ट्रेटेजी बनाते हैं ग्राफ ड्रॉ करने के लिए. ओके, व्हाट इज द पीरियड ऑफ फंक्शन sin x? Its period is 2 pi. Then the period of sin inverse of sin x is also 2 pi. Sin inverse की वैल्यूज हर 2 pi इंटरवल के बाद रिपीट करती हैं. इसका मतलब ये हुआ कि इस फंक्शन का वैल्यू भी हर 2 pi इंटरवल के बाद रिपीट होंगी. That means we will draw the graph of this function for the interval which has length 2 pi, and then we will repeat the graph on both sides of that part of the graph. clearly the values of sine inverse of sine x depend on the values of sine x. Isn't it better if we draw first the graph of function y is equal to sine x? Here is the graph of function y is equal to sine x. From this graph we will draw the graph of function y is equal to sine inverse of sine x. We start with the interval x belongs to minus pi by 2 to pi by 2. For this values of x, sine inverse of sine x is x. That means in this region the graph of the function is straight line y is equal to x. We know how y is equal to x is situated with respect to y is equal to sine x. It is like this. This part of the graph is y is equal to x. Now we will consider interval x belongs to pi by 2 to 3 pi by 2. To draw the graph for this interval, we will take some points. First take x is equal to pi by 2. For this value, sine inverse of sine pi by 2 is equal to sine inverse 1. This is equal to pi by 2. So we have point pi by 2 comma pi by 2 on the graph. Then we consider x is equal to pi. So we have sine inverse of sine pi is equal to sine inverse 0, which is equal to 0. So at pi the value of this function is 0. We have a point pi comma 0 on the x-axis. And then we have x is equal to 3 pi by 2, for which we have sine inverse of sine 3 pi by 2 is equal to sine inverse minus 1. And this is equal to minus pi by 2. So we have a point 3 pi by 2 comma minus pi by 2 on the graph. So we have a graph here for sine inverse of sine x in the interval pi by 2 to 3 pi by 2. Here the graph is a straight line. The slope of this line is minus 1 and it is passing through point pi comma 0. So the equation of line is y is equal to pi minus x. We can also check the values of pi minus x. Here x lies between pi by 2 to 3 pi by 2. So the values of minus x will lie between minus 3 pi by 2 to minus pi by 2. And if I add pi to this, the values of pi minus x will lie between minus pi by 2 to pi by 2, which are the principal values of function sine inverse of sine x. इसका मतलब कि जो हमने स्ट्रेट लाइन ड्रॉ किया था y is equal to pi minus x, वो सही है. Okay, now we have a graph of the function in the interval minus pi by 2 to 3 pi by 2. The length of this interval is 2 pi. The job is done. हमने 2 pi इंटरवल लेंथ के लिए ग्राफ ड्रॉ कर लिया. तो अब हमें ग्राफ को ज्यादा डिस्कस करने की जरूरत नहीं है. हम क्या करेंगे, इस ग्राफ को 3 pi by 2 के राइट हैंड साइड एंड माइनस pi by 2 के लेफ्ट हैंड साइड पे रिपीट करेंगे. So how will be the repetition? The repetition will be like this. ग्राफ जो है वो इस तरह से ट्राइंगल्स बनाते हुए आगे बढ़ेगा. Okay, this line represent function y is equal to x minus 2 pi. The next line represent y is equal to 3 pi minus x. The next one will be x minus 4 pi, then 5 pi minus x, and so on. On left hand side we have this line y is equal to minus x minus pi. This line y is equal to x plus 2 pi, and so on. From the graph we can see that sine inverse of sine x is equal to odd multiple of pi minus x or x minus even multiple of pi. We will use this to find the principal values of sine inverse of sine x. Let's get the values of sin inverse of sin x for some values of x. We start with sin inverse of sin 1. What will be the value? Here 1 lies between minus pi by 2 to pi by 2. Here 1 is radian, it is not degree. Okay. So this value is straight away equal to 1. Now consider sin inverse of sin 2. Now this 2 does not belongs to minus pi by 2 to pi by 2. So this value is not equal to 2. So how we get the value? We do this adjustment. We can write sin 2 as sin pi minus 2. What I am doing? I am adding and subtracting pi. Now sin pi minus theta is sin theta. So we have sin inverse of sin of pi minus 2. Now this pi minus 2, which is approximately 1.14, belongs to minus pi by 2 to pi by 2. So the value of this is pi minus 2. Okay. Try next one, sin inverse of sin 3. Again this 3 does not belongs to minus pi by 2 to pi by 2. So I add and subtract pi like this. This is equal to sin inverse of sin pi minus 3, and pi minus 3 is approximately 0.14, which belongs to minus pi by 2 to pi by 2. So here the value is pi minus 3. Try next sin inverse of sin 4. Again 4 does not belongs to minus pi by 2 to pi by 2. So again we add and subtract pi because the difference of 4 and pi is 0.86, which belongs to principal values of sin inverse of sin x minus pi by 2 to pi by 2. So we have this sin inverse of sin pi minus 4. The answer is pi minus 4. Take one more value, sin inverse of sin 5. Now can we take the help of pi? The difference of 5 and pi is 5 minus 3.14 is equal to 1.86, and this value does not belongs to minus pi by 2 to pi by 2. So here we don't get any help from pi. So we consider next integral multiple of pi, which is 2 pi. The difference of 2 pi and 5 is 6.28 minus 5, which is equal to 1.28, which is in minus pi by 2 to pi by 2. So in this case we will add and subtract 2 pi, but like this, sin inverse of sin 2 pi plus 5 minus 2 pi. Sin 2 pi plus theta is sin theta. अब आपको समझ में आया कि मैंने यहाँ पे बीच में प्लस क्यों रखा, क्योंकि मुझे प्लस sin theta मिलेगा. So we have sin inverse of sin 5 minus 2 pi, and this is equal to 5 minus 2 pi, which is minus 1.28, that belongs to minus pi by 2 to pi by 2. Let's see this values on the graph of y is equal to sin inverse of sin x. जो हमने ग्राफ डिस्कस किया था हम उसको यूज करते हैं. So here we have graph of function. Okay, for x is equal to 1, this value of x falls in the region where function is y is equal to x. That means for x is equal to 1, y is equal to 1. Sin inverse of sin 1 is 1. Now take x is equal to 2. Now this point falls in the region where function is pi minus x. So for x is equal to 2, we have value pi minus 2. Similarly for x is equal to 3 and x is equal to 4, we have pi minus 3 and pi minus 4 respectively. Now x is equal to 5. This point falls in the region where function is x minus 2 pi. So we have principal value sin inverse of sin 5 is equal to 5 minus 2 pi. Let's see now how to get the value of sin inverse of sin x for any value of x without much calculations, particularly when x is very high. In that case, consider one value sin inverse of sin 20. What is strategy to get this value? Now think multiple of pi which is close to 20. 20 के नियर पाई का कौन सा मल्टीपल हो सकता? Maybe 6 pi or maybe 7 pi. Let's consider 6 pi. The approximate value of 6 pi is, you can calculate, it is 18.84. The difference of this value and 20 is 1.16, which belongs to minus pi by 2 to pi by 2. And since we have now even integral multiple of pi, the principal value will be 20 minus 6 pi. हमने साइन इनवर्स ऑफ साइन एक्स के ग्राफ में देखा था कि जब इवन इंटीग्रल मल्टीपल ऑफ पाई आता है तो हमारा ग्राफ होता है x माइनस दैट इवन इंटीग्रल मल्टीपल ऑफ पाई, और जब ऑड मल्टीपल ऑफ पाई आता है तो फंक्शन होता है ऑड मल्टीपल ऑफ पाई माइनस x. एक और वैल्यू कंसीडर करते हैं, साइन इनवर्स ऑफ साइन 35. नाउ which integral multiple of pi is close to 35? We may have 11 pi or 12 pi. Let's consider 11 pi first. The value of this is approximately 34.54, and the difference of this value with 35 is 0.46, which belongs to minus pi by 2 to pi by 2. But here we have odd multiple of pi, then the value of this is equal to 11 pi minus 35. So hope आपको ये शॉर्टकट समझ में आ गया. जब odd multiple आएगा तो वो आगे आएगा, और जब even multiple आएगा तो वो x में से माइनस होगा. Now we have a clear idea about the behavior of the function sin inverse of sin x. Let's use this knowledge to solve some typical type of problems. In that case, consider this inequality sin inverse of sin 2x square plus 4 upon 1 plus x square less than pi minus 3. We have to solve this inequality. Okay, for this we write principal value of LHS. But the principal value of LHS depends on the expression 2x square plus 4 upon 1 plus x square. That means first we will find the range of this function. We know how to find the range of function quadratic upon quadratic, but here we have a term x square and constant in the expression. So let's find range this way. I write numerator as 2x square plus 2 plus 2. In fact, I am dividing numerator by denominator. So I have 2 plus 2 upon 1 plus x square. Okay, now tell me when this expression is greatest. Obviously, 2 is divided by 1 plus x square. So this expression is greatest when 1 plus x square is least, and the least value of 1 plus x square is 1 when x square is 0. So the greatest value of this expression is 2 plus 2 equal to 4. Also when x square tends to infinity, 1 plus x square tends to infinity. That means 2 upon 1 plus x square tends to 0. So the lower limit of this function is 2. However, we cannot get exactly 2. The value will be slightly more than 2. So the range of this function is open interval 2 to 4. At 4 we have close interval. So now we have a value of expression. Okay. Now for this values of expression, what will be the principal value of LHS. The principal value will be pi minus 2x square plus 4 upon 1 plus x square, because sin inverse of sin x is pi minus x when x belongs to pi by 2 to 3 pi by 2, and 2 to 4 is subset of pi by 2 to 3 pi by 2. So we have now this inequality. From both sides we can cancel out pi, multiply both sides by minus, so we have 2x square plus 4 upon 1 plus x square more than 3. Now 1 plus x square is always positive, so we can cross multiply by 1 plus x square. So we have 2x square plus 4 greater than 3 plus 3x square. That means x square minus 1 is less than 0. And the solution of this inequality is x lies between minus 1 to 1. Try this question. Find the area bounded by function y is equal to sin inverse of sin x and x-axis for x belongs to 0 to 100 pi. Okay, we have this graph of sin inverse of sin x. We know the domain of this function is all real number. The graph is spread over entire x-axis. We have to find area bounded by this function and x-axis, but between 0 to 100 pi. So we have to find this area. I am scrolling this. Okay, we have this many triangles from 0 to 100 pi. The period of this function is 2 pi. So what we can do, we can find the area for interval 0 to 2 pi and multiply it by 50. We have 50 such intervals 0 to 2 pi. We have 50 such intervals which has length 2 pi. Also we can do this way, we find the area of triangle ABC. This triangle is ABC. And we have 100 such triangles, 50 triangles above x-axis and 50 triangles below x-axis. So the required area is 100 multiplied by area of triangle ABC. And area of triangle ABC is simple. Length AC is pi and the height of this triangle is pi by 2. So the required area is 100 multiplied by half multiplied by pi multiplied by pi by 2. So this is equal to 25 pi square. Let's use the graph of sin inverse of sin x to relate these two values, sin inverse 2 alpha square root of 1 minus alpha square and sin inverse alpha. Okay, now we have square root of 1 minus alpha square. This expression is defined when 1 minus alpha square is greater than or equal to 0, for which alpha lies between minus 1 to 1. This leads to trigonometric substitution alpha is equal to sin A, because the values of sin A also lies between minus 1 to 1. इनवर्स ट्रिगोनोमेट्रिक फंक्शन का एक इम्पॉर्टेंट एस्पेक्ट है कि यहाँ पे आपका अगर सब्स्टिट्यूशन एप्रोप्रिएट है तो एक्सप्रेशन बड़े आसानी से सिंप्लीफाई हो जाएगा. दैट मीन्स a is equal to sin inverse alpha where a belongs to minus pi by 2 to pi by 2, because we have here inverse function sin inverse alpha. That means we will be considering only principal values. That means a belongs to minus pi by 2 to pi by 2. Let's put this value of alpha in the expression sin inverse 2 alpha square root of 1 minus alpha square. So we have this equal to sin inverse 2 sin A square root of 1 minus sin square A. This is equal to sin inverse of 2 sin A cos A. 2 sin A cos A equal to sin 2A. So we have sin inverse of sin 2A. Now tell me, is this value equal to 2A? 2A is equal to sin inverse 2 alpha square root of 1 minus alpha square. So we have sin inverse 2 sin A square root of 1 minus alpha square. So we have sin inverse of 2 sin A cos A equal to sin 2A. If this is 2a, then our answer will be 2 sine inverse alpha, because a is sine inverse alpha. Tell me, is this correct? Absolutely not. What is the reason? The reason is a belongs to minus pi by 2 to pi by 2. That means 2a belongs to minus pi to pi. These are not principal values of sine inverse function. We know sine inverse of sin x is x only when x belongs to minus pi by 2 to pi by 2. Here the values are overflowing. The values of 2a are minus pi to pi. So this is not 2a. It will be 2a, but with some restrictions. Okay. Now suppose 2a is equal to x. So we have now y is equal to sine inverse of sin x, where x belongs to minus pi to pi. Let's draw the graph of sine inverse of sin x. We have this graph. I am taking this part only because my x is from minus pi to pi. Okay. Okay. Now for x belongs to minus pi to minus pi by 2, this function is equal to minus pi minus x. Next, the interval is minus pi by 2 to pi by 2. Here the function is x, and for x belongs to pi by 2 to pi, the function is pi minus x. Now in each branch we replace x by 2a, so we get this. Now replace a by sine inverse alpha, so we get this. Now 2 sine inverse alpha belongs to minus pi to minus pi by 2. So sine inverse alpha belongs to minus pi by 2 to minus pi by 4. So alpha belongs to minus 1 to minus 1 upon root 2. Similarly, we can calculate the values of alpha for second branch. We get alpha belongs to minus 1 upon root 2 to 1 upon root 2. And for third branch, alpha belongs to 1 upon root 2 to 1. So we have related sine inverse 2 alpha square root of 1 minus alpha square and 2 sine inverse alpha for this 3 different regions or branches. स्टूडेंट्स को इन एक्सप्रेशंस को रिलेट करने में काफी प्रॉब्लम्स आती है. कई जगह पे इसका एक्सप्लेनेशन होता है, बस स्टूडेंट्स उनको समझ नहीं पाते. बट हम देख सकते हैं कि ग्राफ को यूज करके हम बहुत आसानी से इन दोनों एक्सप्रेशंस को रिलेट कर सकते हैं. हम ग्राफ तो स्टडी करते हैं, बट क्या फायदा उस ग्राफ का जिसको हम क्वेश्चंस में यूज ही ना करें. We will see some more graphical applications in many further topics.